Okay, in this video, we're going to talk about the domain and range and vertical asymptote of a log function. Now, if you think back of when we introduced you to functions, we had some restrictions with domains. We want to be able to plug in a value for x and get out something for y, and those values of x that works for is going to be the domain. So, when we run into some restrictions, such as getting 0 in the denominator, we're not going to get out a value for y. Or if we get a negative under an even root, we won't get out a value for y. So those are some restrictions we have with domain. And now with log functions, we are going to add a third restriction to our list of restrictions for domain. We can't take the log of a negative number, and we can't take the log of 0. There is no exponent that I could raise a base to get 0, and there is no exponent that I could raise a base to get a negative number. So for example, log base 3 of 0, that would not exist. There is no exponent that I could raise 3 to and get out 0. That's impossible. And the other example we said was negative numbers. There is no exponent that I could raise 3 to get out negative 3. That's impossible. So we're going to add that to our list of restrictions. So when we look at a log function, if it's been shifted in some way and I have something inside here other than x, and I know that my domain just isn't 0 to infinity, then what I have to do is, since I know whatever's inside here has to be positive, it can't be 0 and it can't be negative. Whatever's inside there, I'm going to set up an inequality and say x minus 5 is greater than 0 and solve that inequality. So I know that my domain is going to be 5 to infinity. This number here is always going to be associated with my vertical asymptote, because if my vertical asymptote is originally at x equals 0, a vertical line at x equals 0, and it's been shifted to the right 5, change with my domain as well. So if I move it over 5, as in this example, my new vertical asymptote would be 5 as well. And then, of course, my range is going to be minus infinity to infinity. Okay. Next example, I have a shift and a reflection in this one because I have a negative in front of the x and I have a 1/4 inside there. Whatever's inside here, I'm going to set it so that it's greater than 0 because I know I can't take the log of a negative number and I can't take the log of 0. So whatever's inside there has to be strictly greater than 0. So I'm going to solve this inequality and I'm going to get x is less than 1/4. So my domain is going to be minus infinity to 1/4. And my vertical asymptote is now going to be x is equal to 1/4. For part C, it says, find the log base 3, the domain, find the domain of log base 3, 3x minus 5 minus 1. Notice that this minus 1 is outside the parentheses, so I'm not concerned about that affecting my domain. I just got to take whatever's inside here and set up an equality so that the 3x minus 5 is greater than 0. And when I solve that for x, I get x is greater than 5/3. So my domain is going to be 5/3 to infinity. And my vertical asymptote is going to be x equals 5/3. Now in this last example, it's slightly different than the previous 3 that we've done, because when I take what's inside those parentheses and I make that greater than 0 and I solve that, I now have a rational inequality to solve. So we're meshing topics here, which is good because it will get us to go back and refresh on older topics. When I have a rational inequality, I have to solve by using a sign chart. Fix that. That should be a 2. So I got to take and put on my sign chart whatever makes the top and the bottom 0. So that's going to be -3 and 2. And I don't want to include 0 in this, and I don't want to include anywhere that's undefined. So these are both going to be open circles here. And in fact, for -3, I'm going to also label that as undefined, because that's what makes the denominator 0. Okay, when I do my test points, I'm going to find that on this interval I've got positive, this interval is negative, and this interval is positive. Since I'm trying to find where it's greater than 0, my domain is going to be from -infinity to -3, union 2 to infinity. Now, when we go to find the vertical asymptote, remember the vertical asymptote is what makes inside the parentheses equal to 0. And since that's a fraction, the only thing that will make the fraction 0 is what makes the numerator 0. And in this case, what makes the numerator 0 is 2. So my vertical asymptote is going to be x is equal to 2. Now for this example here, we're going to now use our knowledge of graphs of logs, their domain, and their vertical asymptotes to determine which equation is matched with which graph. So if we look at the first one, I'm going to have a vertical asymptote at -2 because that's what makes inside here 0. This one is going to give me a vertical asymptote at +2. Because if I plug in the 2 here, that gives me a -2 plus a +2, and that's what's going to make the inside 0. And then for this one, I'm going to have a vertical asymptote at -2. So these are all where my vertical asymptotes are. Now, if you notice, we only have one graph here in which we have a vertical asymptote at +2. That would be the graph of B in blue. So now we have to narrow down the last two. The last two both have vertical asymptotes at -2, so that would be A and C. But if you notice the difference between the two, one has been flipped over the x-axis. So typically, if we have log base 4 of x before any shifting, that's just going to be an increasing log function with a vertical asymptote at 0. When we shift it and add that +2 in there, that's when it shifts it to the left. So now it looks like this instead. And then if I want to flip it over the x-axis, then I put a negative in front of my function. And that will give me a reflection over the x. So this is going to be the graph of C in green because that's been flipped. And this is going to be the graph of A because this has not been flipped. It's still increasing.